Okay, so the next question is if the function g divided by x minus 1, the remainder is 3, and if the function g divided by x plus 1, the remainder is 2, and hx is, or the function h divided by x minus 1, the remainder is 1, and then if hx divided by x plus 1, the remainder is 2. Okay, now this is really important, and the remainder, or the remainder of fx divided by x squared minus 1 is, okay, that's the question, and I want to tell you guys that x minus 1 is actually x plus 1, x minus 1, which is essentially them at the beginning. Okay, and you want to remember that because it's important. Okay, so the first thing here, you have to know the theorem. I don't know, the remaining theorem. I think that's the name of the theory. So if x minus 1, x equals 1, right, and then you have the function x like g1 equals 3, and then do the same to this x minus 1 equals 2, and then do the same to the this if h1 equals 1, h minus 1 equals 2. So you're gonna apply this then. Is this thing on? Okay, this is thing on. Okay, you gotta apply this. Fx equals the function g divided by the function h. So yeah, you're just gonna divide this 3 divided by 1, 3, and the other one, the minus 1, 2 divided by 2, it's 1, and then you insert this to this function px plus q. So the function f1 will have the x equals 1, so I'm just gonna write p plus q equals 3, and then the minus 1 will have the x equals minus 1, right? So it's x minus p plus q, and then you gotta eliminate it, and then you find both the q and p. Okay, p. Okay, and then you gotta rewrite that px plus q, and then px plus q, and then you gotta insert the p and the q, and then the answer is the answer is x plus 2, and then the remainder of the function x divided by x squared minus 1 is this. So that's all for today. Okay, that's all, I guess.